Welcome to David Alexander Maths Tuition. This is chapter 11A on integrating standard functions. So first of all, just a quick recap on how to integrate to begin with. So what we do if we're integrating 2x cubed with respect to x, what we do is we increase the power by 1. So 2x cubed becomes 2x to the power of 4, and then we divide by this new power. So here we're going to be dividing by 4. So it's 2x to the power of 4 over 4, but this can be simplified, and that is exactly the same as x to the power of 4 over 2. And don't forget there is always a plus c, the constant of integration. 3x to the power of 5, if we're integrating that with respect to x, then that's going to be 3x to the power of increase the power by 1, 6 divided by 6, and again 3 divided by 6, that is 1 over 2. So again we can write that as x to the power of 6 over 2 plus c, or we could also write that as 1/2 x to the power of 6 plus c. That's also exactly the same thing. 10x to the power of 7, if we're integrating that with respect to x, then 10x to the 7 becomes 10x to the 8, and divide through by 8. And again we can tidy that up. That can become 5x to the power of 8 all over 4 plus c. So when we're integrating trig functions, we just need to think about differentiation. So for example, we know that the sine of x differentiates to the cos of x. So what that means is that the cos of x integrates to the sine of x. Cos of x differentiates to negative sine x, so negative sine x integrates to the cos of x, and that would also mean that positive sine x would integrate to negative cos x. Tan x differentiates to sec squared x, so sec squared x integrates to tan x. Cosec x differentiates to minus cosec x cot x, so negative cosec x cot x integrates to cosec x, and so on and so forth. So sec goes to sec tan, so sec tan integrates to sec x, and negative cosec squares integrates to cot x. So when we're dealing with trig functions, we just need to be thinking about what happens when you differentiate, and we're just working the process backwards. So here are a couple of examples in action. Now for sec x tan x, now because I've done a lot of calculus, I know that sec x tan x is the derivative, and we can see it over here, this is the derivative of sec x. So if I'm integrating sec x tan x, then that means that's going to take me back to sec x. So this will be 4 sec x plus c. Let's have a look at the next example. So we've got minus 6 cosec squared x. Now I can see that minus cosec squared x is the derivative of cot x, and we can see here it is negative as well. So we've got minus cosec squared x. So if I integrate, that will be positive cot x, but it's minus 6 cosec squared x, so that will be positive 6 cot x plus c. Let's look at this final example. So I've got negative 3 sine x. So I can see that negative sine x is the derivative of cos x. So there's my negative sine x. So that will integrate to positive cos x, but it's negative 3 sine x. So therefore that will integrate to positive 3 cos x plus c, the constant of integration. Let's look at a few more examples. So here I've got the 1/2 cos x. This is what I'm integrating. So I can see that cos x is the derivative of sine x, so that means if I integrate cos x, I'll get sine x, so that is just going to be 1/2 sine of x plus c. 3 sec squared x, I can see that sec squared x is the derivative of tan x, so that will integrate back to tan x, that's going to be 3 tan x plus c. And minus 3 cosec x cot x, I can see that minus cosec x cot x is the derivative of cosec x, so therefore this will be positive 3 cosec x. Okay, so here we are dealing with e. Now e is quite easy to differentiate and to integrate as well. If the f of x is e to the x, we know that it is its own derivative. If we differentiate e to the x, that is just e to the x. So if I'm integrating e to the x, it will be e to the 7x. If the f of x is, let's say, 12e to the x, then if I differentiate, that will just be 12e to the x. And again, what we're doing is we are multiplying this by the derivative of x, which is just multiplied by 1. So, it stays the same. So 12e to the x differentiates to 12e to the x, so 12e to the x integrates to 12e to the x. So all of these are really easy. the integral of e to the x is e to the x plus c, 7e to the x is 7e to the x plus c, and 5e to the x is simply 5e to the x plus c. So nothing to be afraid of when we're integrating e to the power of x. Okay, so here we are integrating 1 over x. So we could write 1 over x as x to the power of minus 1. So we know that when we integrate, we increase the power by 1. So if I increase negative 1 by 1, that will be 0, x to the 0, and I divide by that new power. But we know in maths we can't divide through by 0, so this will not work. So we just need to think, and hopefully you'll get to a stage where you just know this automatically. But what differentiates to 1 over x? Well, if the function of x is the ln of x, then the derivative is 1 over x. So 1 over x, that will integrate to the ln of x plus c. If it's 3 over x, then that is 3 lots of, that's 3 times 1 over x. And we know that 1 over x integrates to the ln of x, so this is just simply 3 ln x plus c. And minus 4 over x, well, that will integrate to minus 4 ln x plus c. So just remember, if you've got a number on top, that comes out the front of the ln of x. So nice and easy, really. Okay, so here we are integrating with respect to x, quite a few bits and pieces. So here we've got 1 over x. Now we just need to remember that 1 over x, that integrates to the ln of x. 3e to the x, well, that just remains the same, despite the fact there's a number at the front. Don't let that confuse you. E to the x is only a problem if it was e to the 2x or e to the 4x, if there was a number next to the x, but if there's a number at the front, that's not a problem. That's 3e to the x. So 4x squared, well, all we're going to do is just increase the power by 1 and divide through by that new power. And what about the sine of x? So I know that the cos of x, that will differentiate to minus the sine of x. So therefore the negative cos of x will differentiate to the positive sine of x. So as I'm integrating the positive sine of x, that will take me back to minus cos x. So it's minus cos x plus c. Okay, minus 4 cosec cot. So we need to remember that cosec x, that will differentiate to minus cosec x cot x. So minus cosec cot will integrate to cosec. So here it's minus 4 cosec cot, so that will integrate to positive 4 cosec x. Minus 2 sine x. So we know that negative sine x is the derivative of cos x, so that will be plus 2 cos x. Sec squared x, we just need to remember, and these are given on your help sheet as well. Tan x, that integrates to sec squared x. So sec squared x integrates to tan x, that's going to be minus 3 tan of x. And this horrible bit here, 1 over x to the negative, 1 over x squared. Well, I would write that as x to the minus 2. First of all, so let's worry about the sign in a minute. So I'm going to increase the power by 1 and divide by the new power. So I'm going to divide by minus 1, and if I just divide by minus 1, that's the same as me just sticking a minus sign right there. And there we go. There we have it. Plus the c, of course. Okay, so here we have a definite integral, so we're integrating 4e to the x between the limits of 3 and 2. So first of all, what is the integral of 4e to the x? Well, it's simply 4e to the x, and that is between the limits of 3 and 2. Okay, so we just need 2 brackets here. We're putting 3 through it first of all, so that's going to be 4e to the power of 3 minus 4e squared. And well, that is our answer. There's not, well, we could factorise out a 4e squared if we wanted to, but we can just leave it as, well, the exam board will tell us how they want an answer presented. But 4e cubed minus 4e squared, that is the exact answer there. Okay, so here we're evaluating a trig function, so we're integrating the sine of x. So I know that the cos of x differentiates to minus sine x, so what that means is that minus cos x differentiates to positive sine x. So the integral of positive sine x is negative cos x. So that is going to be minus the cos of x between the limits of pi and 0. So that is going to be minus the cos of pi minus the cos of 0. So we could use a calculator here, or we could just do a little sketch using our cos graph. So here is 2 pi, here is pi. So the cos of pi is -1. So, but we want the negative cos of that. So if the cos of pi is -1, then minus -1 is +1. Take away, what is the cos of 0? The cos of 0 is 1. So it's -1. So it's 1 minus -1, so 1 plus 1. So we have evaluated that integral. The answer is 2. Okay, here's another example where we are dealing with a definite integral 1 over x. So this is one of the ones that hopefully you'll get confident just with spotting. When you integrate 1 over x, that is the ln of x. So we are integrating, so the ln of x is the integral of 1 over x, and that is between the limits of e to the 4 and e squared. And of course it's common to see a question linking e's and lns. So let's just do our double brackets with a minus sign in between. So it's going to be the ln of e to the power of 4, take away the ln of e squared. And of course the ln of e, well they cancel each other out, so this can simply become 4. Take away ln of e to the 2 is 2, and of course 4 minus 2 is 2. Okay, so 2 is the answer to the integral of 1 over x between the limits of e to the 4 and e squared. Okay, here's quite a nasty question where we've got something we need to integrate, and we've got the answer, and we need to work backwards from this answer to work out what p is in these limits. So first of all, I'm going to try and integrate this thing the best I can, but before I do that, I'm going to simplify it. I'm going to turn that into 4x over x plus 1 over x, and of course 4x over x is simply 4. So what I'm doing is I'm integrating between the limits of 3p and p, 4 plus 1 over x. Okay, now when I integrate 4, that's going to be 4x, and 1 over x, that integrates to the ln of x. Okay, and that is between 3p and p. So what do I normally do with these limits? Well, let's substitute them in. So I'm going to put in two brackets with a subtraction sign in between. So 4 times 3p, which is 12p, plus the ln of 3p, minus 4 times p, minus 4p, plus the ln of p. Let me just take these workings up here. So that is going to be 12p plus the ln of 3p, minus 4p, minus the ln of p. So 12p take away 4p is 8p, plus the ln of 3p minus the ln of p. And that is the ln, that when we are subtracting one log from another, we can write it as one combined log. And because here we are subtracting one from another, when we combine it, that will be a division. So ln of 3p over p. And that is the same as 8p plus ln 3, because these p's can cancel. Okay, so we've got the ln 3. That's nice. So therefore the 8p must equal the 16. So therefore p is 16 divided by 8. So therefore p equals 2. And we're done.